So as part of my job, I join different teams and work on different projects. And my clicker. Okay. So, and as I work on those different projects, I noticed that they often suffer from one of two problems. They are either over-engineered or they are stuck in the 90s. The over-engineered ones involve jumping on every shiny new tool that people see on the first page of Hacker News. And then everyone gets excited because, well, it's fun to work with something brand new. What is not fun is when this tool gets deprecated. Maybe its creator got bored and stopped working on it. So now you have to either fork it and maintain it yourself, or you have to replace it. My clicker is being annoying. Okay. And on the other hand, we have projects that are still stuck in the 90s. Some people think that because it was fine to manage everything using bash scripts back then it's fine to keep using bash scripts today. It's fun if you're a hardcore Linux user and you love writing bash scripts, but to be honest, when was the last time you wrote one? Okay, writing them from scratch is not that bad. Maintaining a bash script that someone else wrote is much worse. And I don't mean that bash scripts are bad. They're actually pretty great for simple things. It's just you should use tools more suitable for the task at hand. So neither of these situations is good. You should update your tools, but at the same time, you should choose those tools that are proven and you know they will be around in the next few years. So that's why I've decided to make this presentation. I want to show you some useful Python tools that will make your life easier, tools that I recommend to my colleagues and to my clients. First, we'll talk about things that a lot of beginner programmers struggle with at some point. So I will show you how to install different Python versions on your computer using a tool called pyenv. Next, I will talk about Python dependencies. I will explain you what are virtual environments, how they work, and why you need them if you work with multiple Python projects. I will also compare the built-in env module with some external tools like the virtualenvwrapper. And finally, we will talk about a tool called pipx. This is a great tool if you want to install some Python package globally, but you still want to isolate it from other packages on your computer. And before we move on, I really want to highlight one thing. Those are all just tools, and there are a lot of other tools that do similar things. If you're using something else, that's great. My goal here is not to convince you that those are the best tools. No, I just want to show you how you can solve some basic problems when you configure your development environment. If, for example, you are using Conda and you're happy with it, then actually the first 2 bullet points on this list are already solved for you, and that's perfectly fine. But if you don't know what to use, let me show you some recommendations. So first, let's talk about installing Python on your computer. Depending on your operating system, your computer might already come with some version of Python. If you're using Mac OS, then it comes with Python 2.7. If you're using Linux, then the version of Python depends on what distribution you are using. And if you're using Windows 10, then you don't have any version of Python installed. Let's say that your operating system comes with some Python version. This Python version already installed on your computer is often called system Python. And no matter what system version of Python you have, I strongly suggest you don't use it. In many cases, as we saw, for example, with Mac OS, it's terribly outdated. Python 2.7 is no longer officially supported by the core developers, and hopefully you are also not using it since a long time. You might be tempted to upgrade the system Python to Python 3, but you probably have some programs on your computer that require this Python 2.7. You would be surprised how many programs or even parts of the operating system still requires Python 2.7, at least on Mac OS. If you update system Python, those programs will stop working. So if you change the Python version that comes pre-installed with your operating system, you risk that your computer will stop working at all. And that is not fun. I have done this in the past when I didn't know much about programming and operating systems, and instead of a fast update, I had to reinstall everything from scratch. So my advice here is to leave the system Python alone and pretend it doesn't exist. So no matter what operating system you have, you will need to install Python. And there are many different ways how you can do this. You can go to the python.org website and download the installer for your operating system. You can use a package manager like Homebrew on Mac or apt-get on Linux. And you can even compile Python from the source files. However, my favorite way of installing Python that I'm using since a few years is to use a tool called pyenv. Pyenv is a tool for managing Python versions. You can use it to easily install a new Python version and to quickly switch between the versions that you already have. It might not be a big deal if you only work on one Python project all the time and you use one Python version. But if you're working on multiple Python projects that require multiple Python versions, this tool is extremely useful. For example, when I do some tutorials and courses, I try to use the latest version of Python. But when I work with my clients, they usually don't have the latest Python, so I have to use some old ones. I've been using Python for years, and it works very well. If you have worked with different programming languages, you might recognize similar tools that work in exactly the same way as pyenv. For example, there is rbn for Ruby, node-env for Node, goenv for Go, and so on. While pyenv will work on macOS and Linux, if you're using Windows, check out the pyenv win. This is a port of pyenv to Windows. It might not have all the features that the standard pyenv has, but it has all the essential ones. But then again, if you're on Windows and you're using Conda, there is really no point in switching from Conda to pyenv. One of the things that Conda can do is to create a virtual environment with a specific Python version, which covers 2 out of 3 tools in the stock. So you can install pyenv with Homebrew, you can clone it with Git and then manually set up a few things, or use a pyenv installer. And while this last option requires you to download a bash script from the internet and run it in your terminal, which is like a big security no-no, it's actually very convenient. It will install not only pyenv, but also some useful plugins. For example, pyenv doctor that you can use to verify that the pyenv has been installed correctly. And once you have pyenv installed, you can use it to install new Python version. To see a list of which versions you can install, just run pyenv install -- list. You will see a huge list of available Python versions. At the top, we have the standard C Python versions, but then we have Anaconda, PyPy, Python, Miniconda, ActivePython, and so on. So all those different types of Python can also be installed with pyenv. If you ever wanted to try PyPy, now you can very easily do this. Once you select a version from this list, type pyenv install and a version number and go make yourself a coffee. I mean it, the installation usually takes a few minutes. There are some additional libraries like OpenSSL that you can pre-install to make this process faster. If you don't have them, pyenv will try to download them each time you install new Python version. So I suggest you take a look at the GitHub documentation to see a list of all the dependencies. So once this is done, you can run pyenv version to see if this new version was installed correctly. We can see it on the list, so it means that we are all set. Now we have to tell pyenv to use this version. And for that, we have to choose one of 3 different levels at which we want to change Python version. We have global, local, and shell. What does it mean? Well, 9 out of 10 times, you probably want to change the global Python version. And to do that, you just have to run pyenv global 3.9.0. And from now on, you are using Python 3.9. Then we have pyenv local. So imagine most of the time you are working with Python 3.9, but you have this one project on your computer that still requires Python 3.7. And for some reason, it's not going to work with any other Python version. So instead of changing the global Python to 3.7 each time you work on this project and then changing it back to 3.9 when you stop working on this project, you can set up a local Python version. And that's where the pyenv local commands comes in. You can run pyenv local, let's say 3.7, and it will set that version for the current folder and all the subfolders. So whenever you go inside this folder, pyenv will automatically change the Python version to 3.7. And when you go out of this folder, it will change back to the global version. This is also very handy when you work with multiple projects and each of them requires a different Python version. So instead of changing the global Python version back and forth, you just have to run pyenv local in each of those folders. And then when you go inside of them, pyenv will automatically change the Python version to the one for a specific project. And finally, we have pyenv shell that changes the Python version for your current shell session. You might want to use it in a situation where you want to temporarily change the Python version you are using. For example, maybe you want to run some code with Python 2. So all you have to do is to run pyenv shell 2.7, let's say 18, and now you can use Python 2. But once you open a new session in your terminal or you close this terminal, you go back to using the previous version of Python. So that's how you can easily manage Python versions on your computer. Let's talk about dependencies in your projects. Let's start with pip. Pip is a package manager for Python. Whenever you want to install a new package, all you need to do is to run pip install and a package name. However, pip has one big problem. Whenever you ask it to install a specific version of a Python package, it will uninstall the previous version from your computer and install the one that you asked for. Let me show you an example of what I mean. Imagine you are a web developer and you want to build a Django website. You start by installing the latest version of Django with pip install Django, and that installs Django 3. Everything works great, and you build an awesome website. So awesome that a client or your boss or maybe a colleague asks you, hey, you're making awesome Django websites. Maybe can you give me a hand and fix my Django website? Their Django website is still running Django 2.2. So you install that specific version by running pip install Django equals 2.2, and pip does what you ask for. And after a few seconds, you start working on your client's website using Django 2.2. So far, so good. But later that day, you discover a bug on your personal website, the one that you created with Django 3. You quickly fix the bug, but when you want to test it, you get an error message saying that Django 3 is not installed. Like, what? I mean, we installed it yesterday. Where did it go? Well, when you told pip to install Django 2.2, pip first checked if you already have Django installed. And you had, but it just wasn't the version 2.2. So pip uninstalled this version and installed the correct one. We just ran into a problem with dependencies management. We have this problem because pip installs Python packages in the side packages folder, and it puts each package in a separate folder named after that package. So Django 3 is placed inside side packages /Django, but when you want to install Django 2, it will also be placed in the side packages /Django folder. So pip has to first remove what's inside this Django folder and then install a different version of Django. If you only work with one Python project on your computer, then you're probably not affected by this problem. But sooner or later, you will need to install different versions of the same package, and you're going to run into issues with pip uninstalling some previous dependencies. The problem with pip is that it installs all the packages in the same folder. So how about we tell pip to temporarily install packages in a different folder, and then we tell our Python interpreter to use that different folder instead. That's exactly what virtual environment does. A virtual environment is a folder that contains a Python installation and any additional packages that you install. When you activate a virtual environment, two things happen. First, you tell pip to install any new package into that folder, and then you tell Python interpreter to use packages from that folder. So now when you try to install some Python packages, pip won't uninstall the previous versions from your computer because it's no longer using the global side packages folder. It's using the side packages folder from this specific virtual environment. So how does it work in practice? Well, first you need to create a virtual environment. Python has a built-in module called venv to manage virtual environments, so we don't even have to install anything. We create a new virtual environment with python -m venv command, and then we specify the name of the virtual environment. In this case, I'm creating a virtual environment called .venv in the current directory. .venv or venv are both a common convention for naming the virtual environment folder. This makes it obvious that whatever is inside this folder is related to a virtual environment. But it also has another benefit. Some code editors like PyCharm or VS Code will recognize this folder as a virtual environment, and they will automatically start using it in your project. Oops, come on, okay. Okay, so we have created the virtual environment. Now we have to activate it. Inside our venv folder, there is a bin folder that contains the activate script. Since it's a bash script, we have to run it with the source command. Of course, if you're using a different shell, there are different files that you can use. For example, there is also activate.bat for the Windows users. Once you activate it, you should see a difference in your terminal prompt. It should now display the name of the virtual environment in the parentheses. So if you see something like that, that's great because it means that the given virtual environment is active. And now we do everything as we would do normally when building a Python project. If we install a package with pip, it will be installed inside this virtual environment. If we run a Python script, it will have access to Python packages from this virtual environment. And if you want to stop using a virtual environment, you just have to run deactivate command. When you call deactivate, it will revert all the changes that activate did. So you will go back to using the global Python version and global pip packages. A typical workflow with a virtual environment involves creating one virtual environment for each of your projects. So if you're working on 2 Django projects, you first create one virtual environment, you activate it, you install Django 3, and you start coding. And then you create a different virtual environment for Django 2.2, you activate it, you install Django 2.2, and you start coding on this other project. venv module is perfectly fine for managing virtual environments, but I want to show you another tool that I've been using for a very long time. It's called virtualenvwrapper, and it comes with a lot of cool features that makes working with virtual environments much easier. You can install it with pip, and it works on Linux and macOS. For Windows users, again, you can use a tool called virtualenvwrapper-win that works pretty much the same. But if you are a happy Conda user, you can really stick to using Conda for managing virtual environments. Virtualenvwrapper stores all the virtual environments inside the .venvs folder in your home directory. And it provides you with some additional convenience methods for managing virtual environments. For example, you can create a new virtual environment by running mkvirtualenv and the name of the environment. For example, mkvirtualenv Django 2 app. But unlike venv module, this time you will create the virtual environment inside this .venvs folder, not in the current folder. Now, if you want to activate the virtual environment, all you have to do is to call work on Django 2 app. You don't have to type this whole path to the activation script. Virtualenvwrapper will figure out what virtual environment you want to activate based on the name you use. And if you forgot the name of the virtual environment, you can list all your virtual environments by running ls virtualenv. With venv, it's impossible to get the list of all your virtual environments because venv doesn't keep a track. Virtualenv stores everything in one folder, so you can easily get that list. And to remove a virtual environment, you can just run rm virtualenv and the name of the environment. For example, rm virtualenv Django 2 app. So now you're probably wondering which one is better. Well, both tools are great, and it really boils down to how you like to use your virtual environment. I use virtual environment mostly because I don't want to type this whole source vn/bin/activate, where of course half of the time I'm in like some subfolder of my project and I get an error saying that vn folder doesn't exist. So I have to actually figure out what's the path to this activation script. No, I just want to type work on Django to app and have the virtualenvwrapper figure out for me the actual command to activate it. And also I create virtual environments that are not connected to a specific project. For example, I have one virtual environment with a bunch of data science libraries that I use each time I need to run Jupyter with pandas or NumPy. And also virtualenvwrapper has some interesting features. For example, you can create a temporary virtual environment that will be deleted when you deactivate it. This is quite handy when you want to test some Python package. But then VNF also has some benefits. So since it stores all the virtual environments in the same folder as your project, your code editor will automatically pick them up. And also when you delete this project, you will delete the virtual environment together with it. Plus VNF is a built-in module, so you don't have to install anything. All right, so we covered how to manage Python packages in your projects. What about global packages on your computer? Some tools are much more convenient to use when you install them globally instead of installing them for each of your projects. For example, we have the code formatter Black, we have the code linter Flake 8, or even the virtualenvwrapper tool that we just saw. We want to use those Python packages across all our projects, or even when we're outside of any project. For example, we would use virtualenvwrapper to first create a virtual environment before we start working on a specific project. But again, if two different tools require different versions of the same dependency, you have a problem. You install one tool and everything is fine. Then you install the second tool, it changes some dependencies of this first tool, and then this first tool just stops working. We could install each of those tools into a separate virtual environment, but it's a lot of hassle to use it like that. Each time we would have to activate that virtual environment first and then remember to deactivate it. I mean, you can do this, but it's a lot of typing, and in general, it's a waste of time. We can easily solve this problem with a tool called pipx. Pipx installs Python packages in separate environments, but at the same time, those packages act as if they were installed globally. You don't have to manually activate any virtual environment to use them. How does it look in practice? Let's say I want to install Black to format some Python code. I run pipx install Black, and after a few seconds, I get a success message saying that Black has been installed, and now I have access to those three commands, Black, Black primer, and Black D. Now I can use Black as if it was installed with pip. It doesn't matter if I'm inside of a virtual environment or not, I will always use this global Black package. I don't have to activate anything, I just run the same commands as I would run if I didn't use pipx. And if I want to install a different version of Black inside my virtual environment, I can do this. This Black from a virtual environment will take precedence over the global Black, and it will be used as long as the virtual environment is active. What else we can do with pipx? We can list all the installed packages to see what commands they offer. We can uninstall a package, and this will also clean up the virtual environment for this package. We can upgrade all the global packages with one command, pipx upgrade all. And we have one very useful command called inject. It will install a pip package inside a virtual environment of another package. You might use it, for example, to install some PyTest plugins. Let's say we want to add a plugin called pytestconf to get the test coverage for our code. We can't just run pipx installed pytestconf because it will install this plugin in its own virtual environment and PyTest won't see this package. Again, because pipx installs every package into a separate virtual environment. That's why we have this problem. So we have to call pipx inject, and this will install the pytestconf in the same virtual environment as our PyTest is installed. And that brings us to the end of my presentation. So let's quickly summarize what we just saw. First, use pyenv to install new Python versions. Once you set it up, it's really easy to install new Python versions and switch between them. Then use virtual environments when you work on different projects and you want to isolate their dependencies. Always make sure to create a separate virtual environment for each of your projects. Python comes with the built-in venv module, but if you prefer a tool with some additional functionality, the virtualenvwrapper is a really great choice. And finally, if you want to install some tools globally, you can use pip outside of a virtual environment, but you risk that if there is some version conflict, they won't work together. So a much better tool to use is pipx that will install each package in a separate virtual environment, but for you, there won't be any difference in how you use them. And that's all I have for you today. Thank you very much for listening. And are there any questions?
Yes. Any questions from the floor?
No questions. Either everything was crystal clear or super confusing.
It seems the audience is a bit shy. Oh, one person. Okay. Okay. So Docker and virtual machines.
So that's a really nice question. I still use Docker. Well, I use Docker in a lot of projects. And basically, I would use pyenv for stuff that is more lightweight, let's say. So if I want to run a single script or something, I don't want to write a Docker file or spin up a virtual machine. I use the local Python version. So I like to use those tools to set up, well, my local development. But when I work on a project, I would definitely go with Docker, and then you don't deal with Python version management in a Docker because, well, you have one version of Python there.
Okay. So any other questions? Okay, I might wait for a moment.
If you have some questions after the conference, you can always find me on Twitter or on my website. I'll be happy to answer any of them.
Yep. All right. So I might wait for a minute. Okay, so I think, well, there may be no question, or some people would like to contact Sebastian not in Zoom, but in other ways of communications. So thank you very much.
Thank you so much for having me.
Yep. And it's very nice to know all the tools that we can use, either locally and globally, and how, and some of the pros and cons of those tools. Thank you.
Thank you so much. Enjoy the rest of the conference.
Yep, same to you.
Thank you.